Hi, this is Shannon Seaver. Today we're looking at 6.4b, part 2 of ratio, proportion, and variation. On our agenda today is to solve some direct variations problems as well as some inverse variation problems. So what is direct variation? If two quantities vary directly, then as one variable changes, the other changes in the same manner. So for instance, if one variable increases, the other one increases. As one decreases, the other one decreases. So the one thing I could think of in real life would be like temperature and the amount of snow melt. So as the temperature increases, the amount of snow melt would also increase. So that would be a direct variation. So here are some example problems of some direct variation. An alligator's tail length varies directly as its body length. An alligator with a body length of 4 feet has a tail length of 3.6 feet. What is the tail length of the alligator with a body length of 8 feet? So on this particular one, we can set it up like a proportion. And we learned about proportions in part 1 of this section. So it would be something like this: 4 feet body length over 3.6 feet tail length. And then, so what is the tail length of the alligator? Well, we don't know, so I'm going to put that here. I'm sorry, what is, yeah. And then the body length here is 8 feet, so it'll be right here. So what we're going to do is cross multiply and divide. So we have 4x equals 8 times 3.6. Going to equal 28.8. And now we divide by 4. And we have x equals 7.2 feet. So an alligator with an 8-foot body is going to have a 7.2 foot tail length. So another example of this is the distance required to stop a car, and this should be car, not care, varies directly as the square of its speed. If 200 feet are required to stop a car traveling 60 miles per hour, how many feet are required to stop a car traveling 100 miles per hour? Now, one very big clue on this particular one is not only does it vary directly, but it varies directly with the square of its speed. So I'm going to say stop varies, distance we call it. Distance varies directly with the square of its speed. So I'm going to say speed on the bottom, and we're going to square that. So when we set this up, we're going to need to remember to square the speed part of it. So 200 feet are required to stop a car traveling 60 miles per hour. So don't forget to square that part. That's going to be equal to x, because we don't know how far to stop a car, going 100 miles per hour. So now we're going to do the same thing that we've done. It's going to be 200 times 100 squared equals 60 squared times x. So 200 times 100 squared is 2 million. And 60 squared is 3,600, or 3,600. Now I'm going to take 2 million, divide that by 3,600, and I get 555.5. It's a repeating 5 actually, but we're saying just 0.5 x. So it takes a car 555 feet to stop if it's going 100 miles per hour. Now I want you to take some time to try yourself, stop the video, and come back and check the answers. Okay, so for this first one we got 66 gallons, and on the second one we got 4,087.5 feet. Now let's look at inverse variation. This one is the opposite of direct variation. Remember, in direct variation, when one variable goes up, the other variable goes up. But in an inverse variation, when one variable goes up, the other one goes down. And I can think of deer population versus wolf population. If the wolf population's up, the deer population is probably down because they're getting eaten by the wolves. So that's one example of an inverse variation. So let's look at a problem from this. The distance from Atlanta to Orlando is 450 miles. And if you average 45 miles per hour, the time to drive is 10 hours. If you average 75 miles per hour, the time to drive is what? So really in this particular one that we're looking at, the 450 miles is not important to us. We're just looking at the other three underlined components here. Now, the textbook suggests an interesting way to set this up, and I'm going to tell you this way here. My suggestion is to set it up this where you're multiplying time 1 times miles per hour 1. This to me is confusing. You can do it that way if you wish. However, just remember with inverse variation you're multiplying, direct variation you're dividing. So let's do this. Time of the first one, it was 10 hours. And the miles per hour was 45. That is going to be equal to x. We don't know how long, but we do know that it was going 75 miles. So this will be 450 equals 75x, and then we're going to divide 450 by 75, and that is 6. So it's going to take the person around 6 hours to drive at 75 miles per hour. Now I want you to take time to try this one. So on this particular one, we got a turning radius of 32 feet. I'm sorry, 32 degrees. We're looking at the banking angle. We were trying to find the banking angle. So we found the banking angle to be 32 degrees. All right. So that is the end of this video. If you have any questions, bring them to class tomorrow.